Hey everybody, Mr. Covey here, and today we're going to be talking about finding characteristics about your polynomials from your calculator. This is actually basically all stuff that you already know how to do that we've already discussed, but it was something that we had a lot of issues with on the final. So it's kind of something that I just want to go back and go through. There's a lot of tricky calculator stuff. I want to make sure that we got it all kind of down. There is a teeny bit of new vocab I want to throw at you and one new idea, but then mostly it's going over calculator stuff. The first piece of new vocab is this word turning point. Okay. And when you have a polynomial function, the turning points are points where it goes from increasing to decreasing or where it goes from decreasing to increasing. They're tops of mountains or bottoms of valleys, okay? Those are called turning points. It's where the graph turns. It's going up, 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 turn, then it's going down, turn, then it's going up, okay? So those are called turning points. An important thing to note about turning points is, and this is some vocab we've used previously, if you have a turning point where it's going from increasing to decreasing, that turning point is actually a maximum, and we call it a local maximum. The other word you'll see, and we've used, is it might be called a relative maximum, okay? It's not the highest point on the graph, because the graph goes up forever and ever and ever, but it's the highest point relative to the ones around it. If you look at it locally, excuse me, if you look at the graph locally, in other words, right around, oops, I'm having some, sorry, give me a second. Right around that turning point, that point is the highest point. So if you look right around there, it's a maximum. That's what we call a local maximum. If you have a turning point where it goes from decreasing to increasing, like right there, that turning point is a local minimum. Okay. Also, you could call that a relative minimum. Okay. Determining the relative maximums and relative minimums helps you determine also like where the function is going from increasing to decreasing. So you can see here, like between that green dot and that purple dot, that's where it's decreasing. To the left of that green dot, that's where it's increasing. To the right of that purple dot, that's where it's increasing as well. And you did this on the final, but I just wanted to go over it again. New important concept that I think some of you have picked up on, but I just wanted to make crystal clear is if you have a polynomial of degree n, any number, second, third, fourth, fifth, sixth, seventh, it has at most n minus 1 turning points. Okay. And the reason that this is a useful idea is for a couple of reasons. But most importantly, if you come across a graph, let's say like this, and you glance at it and you go, wait a second. That graph has 2 turning points. It's going up, up, up. It's increasing, increasing, increasing. Turning point, decreasing, decreasing, decreasing. Turning point, oops, sorry. Turning point, increasing, increasing, increasing. Because it has 2 turning points, if you're asked what degree this polynomial is, it has to be at least 3rd degree. It has to be at least 1 degree more than the number of turning points. So this could be 3rd degree, or it could be 4th degree or 5th degree or 6th degree. You don't know, but it's at least 3rd degree. It can't be 2nd degree, and you know this can't be 2nd degree. 2nd degree functions are are parabolas or quadratics. This doesn't look like that. Okay. This also applies to something like, you know, if you came across a graph like that, you'd look at that and you'd say, it's got 1 turning point, 2 turning points, 3 turning points, 4 turning points. It's at least 5th degree. Could be 6th degree, could be 7th degree, could be 8th degree, could be 9th degree, but it's at least 5th degree. That's just a good concept to have. Okay, now to the calculator stuff, the core stuff. So again, we've done this, but I want to reiterate it. I want to graph this function using our graphing calculator. I want to identify x-intercepts, local maximums, local minimums, and determine where it's increasing and decreasing, those intervals. Okay, got to have your graphing calculator, grab it real quick and graph this guy, please. Okay, so this is what the graph looks like, and I want to really find, like, that the way to do this the best way is you want to find that top of the mountain right there, that relative maximum. It's like up there. Sorry, it's hard to point at. And that minimum that's down there. And the way to do that in your calculator, remember, is you go second, calculate. This is where everything good is. Okay, so second trace goes into this menu that has everything important. Okay, what we're going to find first is the maximums and the minimums. So to find a maximum, you hit enter there. We're trying to find that maximum there, but we can't quite guess it. So it says, hey, go a little bit to the left of that maximum. That's why it's saying left bound. I'm going to hit enter. Now it says right bound. I'm going to go a little bit to the right of where that maximum is. I'm going to hit enter. Then it says guess. It wants us to guess where we think the maximum is. So I'm going to go over to right where I think the maximum is. I'm going to hit enter, and it's going to calculate the maximum for me. So it says, hey, at x equals 0, y equals 6, you have a maximum. Okay, the calculator is telling me that information. Let's write that down. At 0, 6, I have a maximum. So my maximum would actually be at 0, 6. Okay, so that's where I have a relative or a local maximum. Okay, now I'm going to go back to my calculator. I see that over here, there's a minimum, but I don't know exactly where it is. Don't assume it's at whole numbers. It could be at 2.1, 3.6645. You don't have no idea. Ask our calculator. We're going to hit second calculate. This time we're going to use not the maximum, the minimum feature. Again, read what the calculator is asking you, and it makes a lot of sense. Left bound. Okay, it wants me to put a left bound. I want to go a little bit to the left of where I think the minimum is. Right bound. Go a little bit to the right of where the minimum is. Hit enter. Guess where you think the minimum is. Hit enter. It's going to tell you where the minimum is. Now be smart here. It says 1.9999. It means 2. So the minimum happens at 2, 2. Okay? So I have a relative minimum at 2, 2. Aside from that, I didn't know what the shape of this graph looks like. It goes up and down and like that. Okay. The one other thing I'd want to figure out, though, is this x-intercept. I only have one x-intercept, but I'm going to calculate it with the calculator. Again, you could guess where you think it is, but you might not be exactly right. It might be at a decimal. So I'm going to use the 0 function. Why am I using the 0 function? You guys know 0 is another name for x-intercept. Okay, so I'm going to use the 0 function, and it works the exact same way. Trying to figure out this x-intercept, says left bound. I'm going to go a little bit left of the 0. Right bound. Notice I'm hitting the right key to go to the right of it. It says guess where you think the x-intercept is. I don't know, around there. It tells you. And in this case, it wasn't at a whole number, so you weren't going to be able to guess that from your calculator. Negative 1.20 is an x-intercept. Okay. Let's plot that point. I plotted a relative max, a relative min, and an x-intercept. I have the general shape of the graph, and so now I'm ready to sketch it. Let's go up and make sure that we're giving them everything they want. X-intercepts, check. Relative max, check. Relative min or local min, same thing, check. Increasing and decreasing. There's no way for it to ask your calculator where the function's increasing or decreasing. That's because once you know the relative maxes and mins, you need to be able to figure it out. So if you look at where this graph's going up, it's going up here. Oops. And here. You'll notice those turning points, those mins and maxes, help define where it's increasing and decreasing. So it's increasing. Please remember this is x values. From negative infinity all the way to the left, it stops increasing right here at an x value of 0. Okay, so it's increasing from negative infinity to 0. These are x values. Some of you guys had that mixed up on your final. Okay. Also, it's increasing from here to the right. What's the x value here? 2. So from 2 to infinity, it's also increasing. Where is it decreasing? Well, it's decreasing between that max and that min, from an x value of 0 to an x value of 2. It's decreasing. So it's decreasing from 0 to 2. Okay? I need you to be able to get all of that information from your calculator. There's no good way to get that information besides asking your calculator. Okay, you're not going to be able to figure that out until calculus class without a calculator right there. Okay. All right. I want you to go ahead and pause and try B. Unpause, and we'll go over. Okay. I'm going to stop partway through this, make sure we're on the same page, and then we can finish it up kind of together here. So here, let me throw that on there, just so I'm confused. Okay, so we're looking at this one. I threw up my graphing calculator. I got this maximum right here. I got this minimum right there. Got these x-intercepts. I'll go over that process one more time just in case we're having any issues. Let's talk about like how I figured out this x-intercept. So I went to my calculator and I saw that over here there was an x-intercept. I went second calculate. I went to 0. I wanted to go a little bit to the left of that x-intercept. So anywhere here would be fine. My cursor is right down here because the graph's down there, but I'm to the left of this x-intercept. Okay, you can see my cursor comes back up there and there it's to the right. So now I'm down here right now. I'm at 4.8. I'm to the left of it. I'm going to hit enter. I'm going to go to the right of it. You can see my cursor fly up there because it's going to the right of it. The graph's just really steep here. I'm going to go back. Now I'm in the middle, taking a guess. The calculator spits out the x-intercept is 5.03. And the y value is -1e to, anytime you say that, it's scientific notation. It's telling you 0. So this point is negative, excuse me, it's 5.03, comma 0. Okay. All right. The one tricky thing about this graph was you see how it goes down here off the graph? I think you guys know what happens down here. You can kind of predict, you're like, oh, it goes down here and then it swoops down somewhere. I don't know how far down it swoops down. Or a calculator can tell us. Okay, so reminders here, the window is what decides how big the graph is. I want to go further down. So what I want to be bigger is my y minimum. Instead of going down to -10, I don't know, let me have it go down to -100. Who knows how far down it goes? Now my graph looks like this because it only goes up a little and goes way down. But look, oh, I can actually see the bottom there. So if I want to calculate that minimum, I go second calc, do the minimum thing, same thing we've been doing, okay? I go a little bit to the left of the minimum. I'm going to go a little bit to the right of the minimum. I'm going to guess where I think the minimum is. My calculator is going to tell me that minimum happens at 3.96, -43. So I have another relative minimum at 3.96, -43. And it's off my graph, so I don't have to graph it, but it's important to note that it's there. It's another relative minimum. Remember, you can always change the window. Change what the far left is, change what the far right is, change what the down is, change, excuse me, what the up is. All of these things will help you get a better picture of the graph. Okay. And lastly, increasing, decreasing. Again, not too hard, just kind of annoying here. So where is it increasing? Well, from here to here. So from -0.6 to 1.1, it's increasing. It's going up there. It's going down. And then at this minimum, from there to infinity, it's going up. So from 3.96 to infinity, remember increasing, decreasing, we're talking about x values. So from 3.96 to infinity, it's also increasing, which is accounting for all that chunk of the graph. Where is it decreasing? Well, here, so negative infinity to -0.6, decreasing. Oops. Negative infinity to -0.6, And then it's also decreasing down here. So from, sorry, 1.1 to 3.96. It's also decreasing. So 1.1 to 3.96. Again, these are all x values. That's the other chunk of the graph where it's going down. Okay. I'm going to pause there on this video. The rest of this you can do as some practice, or you can do the other practice worksheet that we have. But this is an important skill that I want to make sure that you remember. And that concludes this video.